Over the course of Math 1, we've looked at three main different kinds of functions or equations. We've looked at linear, exponential, and quadratic. And what we want to do today is compare and contrast them and look at some of their kind of key features so that we know what kind of equation we're dealing with. So we're going to start with linear. Linear is the one that we're probably most familiar with. And let's think about those equations first. The most common linear one that we dealt with was the slope-intercept equation. So y equals mx plus b. Now notice in that equation, our x and our y do not have exponents. That's kind of going to be the big sign that you've got a linear equation. We could have them in other forms though. We could have something like standard form, ax plus by equals c. So they can be on the same side, but notice there's still no exponents. We also have those funky horizontal and vertical lines where we had an equation just like x equals some number or y equals some number. Those would still give us a linear function. So in all of these, there are no exponents. This is the big thing I want you to take away. No exponents attached to the x in particular. Linear function, hence the name linear, sounds like a line. You're going to get a graph that is some kind of a line. Might be diagonal, might be straight up and down, but it will be a perfectly straight line. The other thing, when we look at it in a table, these are going to be patterns of repeated addition or subtraction. So just like an arithmetic sequence. But we want a constant repeated addition or subtraction. We call that the slope, if you remember that word as a quick little review. And that's how we would tell just from looking at a list of numbers if we have something that's linear. For exponential, our exponential function pretty much always took this form. We had y equals some number times another number to the x power. So big thing there is that the x has to be in the exponent. I'm going to make a note of that. So we've got the x in the exponent, which is super easy to remember because they're called exponential equations. And so that's going to be, if you're looking at an equation, kind of your signal, oh, this is exponential. When we talk about an exponential function's graph, it's going to be kind of J-shaped. So it may go up, may go down, may curve the other way, but it's going to curve up on one side and kind of level off on the other. These are formed by repeated multiplication or division. So just like a geometric sequence, we've got repeated multiplication, which is how we write it, but it may also look to you like division. Now we've done just an introduction to quadratics. In our class, you'll spend a lot more time next year looking at more quadratics, but for the basics, we've got some version of y equals ax squared plus bx plus c. So we're looking for the largest exponent to be 2 for a quadratic. So when we see that x squared, that's what's telling me I've got a quadratic or a parabola, if you remember that word from last week. So a parabola is going to be that U-shaped graph. It might open up, it might open down. Now, I think it's kind of easy to mix up. Both of the exponential and quadratic graphs are just curved. So we don't want to describe them just as curved. We want to just be a little bit more specific. So the quadratic's going to give you that full U shape. Exponentials is a little more J-shaped to where it levels off on one side, curves up or down on the other. So these patterns, for our purposes for right now, and again, you'll get into this more in Math 2, if we were looking in a table or at a list of numbers, we want to look for symmetry, and I'll show you what that means when we see an example. But think about, we learned about that axis of symmetry and how this graph is the exact same on both sides. So we're going to look for that in a table as well. Got examples of equations, graphs, and tables on the next slide to make sure you know how to identify each of these. All right, so up at the top, we want to identify each of these types of functions from an equation. If you think you know what's going on, go ahead and pause, give it a try. I'm going to talk you through how I would know what each one is. Remember that f of x notation is just the same thing as saying y equals. So like in example A, that means y equals 3x plus 2. Just a different notation that we want you to start being more familiar with. So in example A, I see no exponents. I've got just a regular x. That one is going to be linear. That graph would make a line, and you are welcome to graph these and confirm that on Desmos if you want. For B, I have an x in the exponent, So this would be exponential. C just says f of x equals 2. So remember, that's the same thing as saying y equals 2. That's one of our special lines. That would be a sideways line, but it is going to be a line. So those are kind of tricky, I think, when you have no actual, when it doesn't look like slope-intercept form, like example A. But that does make a line, and again, you can graph it to confirm. D, our x is up in the exponent again. So that one would be exponential. And E, I see that I have an x squared, so I'm looking at that exponent in particular. If my biggest exponent is a 2, that's going to be a quadratic. All right, in a table, we've got one of each for you in this table. So we've got, notice on the left side, my numbers are increasing steadily, my x values. When I check out that right side, that's going to be what we really care about. I notice it's going down by 3. Every time. So this is repeated subtraction, which is going to give us a linear pattern. And this is another one. You could graph these points if you wanted to and actually look at the graph and see that it makes a straight line. In example B, we've got a pattern of multiplying by 2. And if it was hard for you to see it from that 1.5, jump to the next number. 3 times 2 is 6. 6 times 2 is 12. When we have repeated multiplication, this one is going to be exponential. And then the last one, because I told you there was one of every kind, is going to be quadratic, but let's look at why. So we talked about how quadratic graphs are the same on either side of the axis of symmetry. So I want you to notice the symmetry in this table. So we go, use the laser, we go from 6 to 3 to 2, so we're going down. And then we go back up the same way, 2, 3, 6. So there is some symmetry there. Some tables that's a little bit harder to see, but we're looking for that symmetry in our table, which means we could literally fold this graph in half and it would be the same on both sides, or we could fold the table in half and it would be the same on both sides. So that's what we're going to focus on for quadratics. I think the easiest one is a graph. So straight lines are linear. And on your paper, as far as if you did not print the notes out, I would just sketch a rough picture of the graph. These don't need to be perfect. Don't spend your time doing that. The next two graphs actually both have that kind of J shape. So notice this one kind of levels off on the left but curves. That's what we call exponential. It's only going up one direction. We can also confirm with the numbers. We go from 2 to 6 to 18. We're multiplying by 3. So we can confirm it that way too. In example C, we have the curve but going the other way. So we had 27, 9, 3. We're dividing by 3 or multiplying by 1/3. That one is also exponential even though it's going the other way. But we're looking for that curve that goes on one side, levels off on the other. And final example in D, we've got this U shape, upside down U shape. We call that a quadratic. We know that's a parabola. So that equation, that graph would have some equation that has an x squared in it. The activity that you do to practice this will count as a quiz grade, so make sure you do that. Ask your teacher if you need some help, but this should be, it's a Desmos activity and should be a great quiz grade for you guys to get some practice and also boost your quiz averages.